Hello, my name is Mark Higgins and welcome to the EUMETSAT roundup of the 2017 world of weather as we've seen from space. What we're going to do is point out some of the meteorological things you can see during the course of a whole year, as well as some of the features about the satellite system. So you'll be able to see that we can see the whole Earth, and that's due to a great international collaboration between ourselves as the weather satellite provider for Europe, as well as we've got here data from China, Japan, and the US. You'll see as we get particularly strong storms, some of the storms that were named, the name will pop up on the screen and we'll show you the track of that storm. During the whole video, you're going to be able to see the flow and ebb of the weather patterns as the clouds, particularly in the north and the south, move from the east to the west in this kind of great flowing cycle of storms. And you'll also see in the equatorial regions, those summer storms, the big pulsing areas of convection. So these cause the great heavy rainfalls that you see in the tropical areas. You'll also notice, particularly in the poles, there's a slight pulsing effect of the clouds. That's not a natural phenomenon, that's due to how often we're able to capture images of the clouds. So in this case, we're also merging in data from polar orbiting satellites. These are satellites that pass over the north and south poles, so that we can actually see the clouds in those areas. From the geostationary view, we don't get to see above, say, 60 or 70 degrees north, so we have to use the polar orbiting data to do that. So here we are in the middle of March. It's spring in the northern hemisphere and coming up for autumn in the southern hemisphere. You can see the equatorial region in the center. Just cast your eyes there for the moment. You'll see there's a pulsing effect, and that's due to the heating of the surface, the developing of these convective storms that then carry on into the evening and then decay in the early morning, and then the cycle starts again. If you follow that band of cloud, you'll see it slowly drifting north towards as we get to northern hemisphere summer, and then drifting south again. You'll see in the southern hemisphere, because of the openness of the oceans, that these storms can just flow from the west all the way across to the east, and there's plenty of sea just for those storms to flow across with no interaction with the land. You'll see in the northern hemisphere, particularly when we get to the northern hemisphere winter, the storms don't quite work the same way. And of course, that's because when the storms hit the land, that land-storm interaction, there's lots of friction from the land surface, that stops the storm traveling. So when we get to northern hemisphere winter, you'll see those storms behave differently. You'll also notice the shape of the northern and southern hemisphere storms. The shape is roughly the same, but one looks kind of a mirror image of the other. And that's due to the rotation of the Earth. It's the rotation of the Earth that gives these storms these spins. So they have the same view as you look towards the equator. So the storm center will kind of spiral out towards the equator. So we're now well into northern hemisphere spring, early summer. And what you'll start to see is some of those convective storms getting triggered in the central plains of the US, in the central plains of Europe. And what they look like is these very, very bright, short lifetime clouds. So you get moisture coming in from the coastal areas, coming in inland over areas that the sun has been able to heat. This causes that air to rise very rapidly. The moisture in it now precipitates out as very, very heavy rain. And quite often, particularly in the US, you'll get tornadoes associated with some of these storms. So the ability to forecast these rapidly developing, very localized storms is one of the real current challenges in weather forecasting. We know that there'll be storms in a certain area, and the challenge of weather forecasting today is to work out exactly when and exactly where will they be, particularly how you get the best you can out of the current and new satellite data. In mid-June, we now start to see the first of the Atlantic storms being triggered. Now, these storms start out as waves in the atmosphere traveling across Africa. They come across into the Atlantic Ocean just off the coast of Africa. The storm then starts to get a bit organized. We start to see a bit of rotation. And once a storm has reached a certain strength and structure, particularly in the wind, so certain strength and wind, it then becomes a named storm. And you'll see the typical track of these storms is to travel across the Atlantic towards the Caribbean and then curl north. These are for the Atlantic storms. But you'll notice it's not just the Atlantic that these storms happen in. And the Pacific season is also just starting. So the same latitude and the same effect again. So you've got waves in the atmosphere, patterns of cloud then start to organize into rotation. And once you've got some rotation passing over warm water, this warm water can really give storms a lot of energy, and that's what keeps them structured and developing. And then they'll travel and keep on developing either until they travel over cooler water to remove some of their energy, or they hit land. Once they hit land, of course, they then start to experience friction, and that helps the storm decay. And you'll see that some of these storms can be really long-lived. So here we have Typhoon Aru in the northern Pacific Ocean, just heading towards Japan now. And you'll see this storm lives for quite some days before it then travels up the western seaboard of the Japanese coastline. So just follow that storm as it travels, and you can see that really well-formed eye structure that really defines the center of the, in this case, typhoon. Turning back to the Atlantic storm season, that was Storm Franklin just traveling across. So it was a very active and very strong cyclone season this year. And of course, many of the cyclones were in the news. So that was Hurricane Gert, and the next one we'll see is Hurricane Harvey, which starts out, gets named in the Mid-Atlantic, travels through the Caribbean, and then becomes re-energized as it comes into the Gulf of Mexico. So drawing off that warm water in the Gulf of Mexico before it hits the southern coastline of the US states there in the Gulf Coast. And that storm maintained a lot of energy even though it was over land, and brought a huge amount of precipitation and flooding into the Texas coast. This is then quite quickly followed by Hurricane Irma, which traveled across some of the Caribbean islands, which was closely followed again by Hurricane Jose. These storms were incredibly well forecast, in this case by the regional hurricane centers. And so warnings were able to be provided. And that really prevents a lot of life being lost and a lot of damage not happening. However, these storms are so strong that damage is inevitable. And so it's really quite a partnership between the weather services and the civil protection agencies in all these countries to make sure that the damage of these storms is minimized. Hurricane Maria now, which was the storm that had a great effect on Puerto Rico. What made these storms so strong during this particular season was the warmth of the water surface. So there was a lot of warm water available to give energy to the storms and keep them developed. So you would have seen a little wobble in the images there on the night of the 3rd of October. And we just lost a few of the images in the North and South Pole. So our little interpolation scheme that keeps the clouds moving slowly has had to cope with a gap in the imagery there. Here you see now mid-October, so 10 through 12, you start to see Hurricane Ophelia forming. It travels across through the Azores and then past Portugal. At this particular time, when we went in these images, there were a lot of land fires in Portugal. It was a really bad fire season, both in the US and in Portugal at this particular time. And this storm, as it came through, actually took a lot of that cloud. It exacerbated the storm situation in Portugal and brought a lot of the smoke north across northwest parts of Europe. So here we are at the 20th of October, and you can see the storm just there in the Atlantic. This becomes Storm Brian, second named storm of the Atlantic season, travelling across the UK, bringing a really heavy rainfall to the UK, Ireland and a lot of Western Europe. So the storm naming convention came out of a conversation between the UK and Ireland, wanting to really make sure that citizens were able to react to the weather forecasts that they were issuing when there was something to react to. So instead of just saying, look, it's going to get windy or there's going to be lots of rain, by giving the storm a name which is linked to warning criteria, the weather services are then much more able to generate response. And that's what helps keep people safe. So now we've reached the middle of Northern Hemisphere autumn and Southern Hemisphere spring. And you'll start to see those storms, the North Atlantic storms that we often experience in Europe, traveling across the Atlantic, much more organized systems than they say were in summer. You'll notice those storms are still traveling around, although it's spring in the southern hemisphere. You're still getting this circulation across the southern hemisphere, but it's much weaker, and the systems are a little bit further north. But you can see the systems in the north much stronger now, traveling across the US, across the Atlantic, and then over into Europe. You may be interested to look at some of the storms as they cross over the southern tip of Greenland. Greenland is incredibly mountainous and has quite an effect on low pressure systems as they travel past. So you'll see that often changes the track or the intensity of the storm as it passes by Greenland. And that can make a storm pass north up through Iceland or south across the rest of Europe. We've really been assisted this year for the 2017 video and putting the whole thing together by our colleagues at the Météo France Centre de Météorologie Spatiale, who have really helped us out by providing these images.